We proceed in some some series and integral calculus. Okay, so we will proceed in some series and integral calculus. The war we have waged, that can we really calculate the summation through integral calculus? Okay, what example we are trying to take now? We will take banking example today. Banking example. Banking example in a sense that there is a fixed deposit. There is a fixed deposit, and in fixed deposit in the bank, if someone is depositing Y0 money, there is a bank, and in bank there is a fixed deposit. A person has deposited some money in the bank, and bank is giving compound interest of C percent compound interest every year. Means if he has deposited Y0 means Y bottom right as a subscript 0, Y0, Y0 means money that has been deposited in the bank account in fixed deposit account when time equal to 0 at the beginning. Y0 money someone has deposited, and money would become at the end of 1 year Y0 plus Y0 into C, Y0 into 1 plus C. Okay, that is the amount that someone can expect at the end of 1 year. At the end of 1 year. Makes sense? Okay, now consider that this compounding is happening every year. Every year, principal amount will get added to the interest amount, and it will become a new principal amount at the end of 1 year. If that is the way, then after t year, t in a small, after t year, y0 money will be y0 in bracket 1 plus c bracket close to the power t, where c is in percentage. If it is 8%, then it will be 0.08 or 8 by 100. That is c. Okay, there is some another bank, he is saying that we are giving C%. That is true. But compounding will happen every month. Every month means Y0 in bracket 1 plus C by 12. C by 12 bracket close to the power 12, that you will get after 1 year. And it will be more than what you are getting every year compounding interest. Y0 in bracket 1 plus C by 12 in bracket close to the power 12. This you will get at the end of 1 year. Okay. At the end of t years, then you have to multiply by t. Y0 in bracket 1 plus C by 12 bracket close to the power 12 into t years. This is what you will get. Okay, some bank may say we do compounding every day. Beginning of the day, whatever the principal amount is, end of the day, principal plus interest will become new principal for the next day. Then the y amount at the end of t years will be y0 in bracket 1 plus c by 365 bracket close to the power 365 into t. If someone is saying that we are doing compounding even more granular to the year, granular to the day, then someone will think how much granularity is coming in within an year. If someone is saying 12 months, then I have to divide C by 12. If someone is saying per day, then I have to divide C by 365. If someone is saying per hour, then it will be 3 by C by 365 into 24. Like that it is growing. If I say I am dividing an year into n part, then it will be y equal to y0 in bracket 1 plus c by n bracket close to the power n into t, where t is number of year, n is number of time. We are dividing the year. Okay, a person is watching very clearly, avid watcher. Y0 plus 1 plus y0 into 1 plus c by n, c by n to the power n. 1 plus c by n bracket close to the power n, where n tends to infinity. It will be same as e to the power c. So it will become y0 e to the power c t, where it is going for continuous compounding. So if someone is saying, I'll give you continuous compounding, what do you mean by continuous compounding? Every minute. Someone will say, every second compounding I'll give you. In that fashion, formula that was initially y0 in bracket 1 plus c to the power t will transform into y0 e to the power ct. Make sense? Okay, now consider another case when there is a guy who is my friend and I don't know he is that nice, and end of every year, he is depositing S amount in the fixed deposit account by his own. He is very generous, okay, towards me. So he is coming at the end of 1 year and then he is depositing S amount in the account. The next year he will come at the end of year and he will deposit S amount. This is what he keep on doing up to T years. So at the end of T year, he has deposited S amount T times. Okay, then what is the amount at the end of T year? Y as a function of T at the end of T year, what is the amount? Y0 into e to the power ct. That's the amount that will become, because whatever you deposit, that amount will start growing in interest, compound interest. So y0 after t year, it will become y0 into e to the power ct. Okay, first S amount will become S into e to the power c t minus 1. Next S amount will become S into e to the power c t minus 2. Next S amount will become e to the power S e to the power c t minus 3. So net computation will be yt equal to y0 e to the power ct plus S, and in bracket e to the power c t minus 1 plus e to the power c in bracket t minus 2 plus e to the power c in bracket t minus 3 plus e to the power c t minus t e to the power c e to the power 0 1. At the end it is 1. Now can someone calculate what is this? Y0 e to the power ct is understandable, plus s, and then e to the power c in bracket t minus 1 plus e to the power c bracket t minus 2 plus e to the power c bracket t minus 3, like that, plus e to the power 0 1, that is 1. How much this summation will be? Okay, now to solve it, let's divide this problem into t number of parts. T number of parts. First part is e to the power c t minus 1. Next part is e to the power c t minus 2. Next part is e to the power c t minus 3. Like that, at the end we have e to the power c t minus 2. Each part is different. Can I make each part look exactly same? Yeah, it's possible. If in the name of constant minus 1, minus 2, minus 3, we'll say minus x, s e to the power c bracket t minus x, t minus x. Now all are same. Now we will solve this problem through two different ways. First way is repeated addition and another is world famous, that is successive approximation. What is repeated addition? What is right now what we are adding? We have divided our summation into t different parts. Each part is e to the power c in bracket t minus x. All parts are same. E to the power c in bracket t minus x. Like that, all parts are same. Okay, in notebook I am writing e to the power c t minus x plus e to the power c t minus x plus e to the power c t minus x plus like that. How many times I have to add? I have to add t times, small t time. Okay. Now consider I have to add 5 plus 5. Every time I give this example only. 5 plus 5 plus 5 plus 5 up to t times. How many it will be? I would rather say 5 into x. This is what I'll say. 5 plus 5 plus 5 plus 5 t times I can rewrite as 5 into x, where x is t. Make sense? Or 5 dx. Integration x is from 0 to t. Same. Similarly, if I have to add e to the power c t minus x plus e to the power c t minus x, how many times? T times. Then I can write as e to the power c in bracket t minus x come down into x time, where x is t. Makes sense? E to the power c t minus x into x. This is typically form of function over x multiplied by x. This will fall in the Typical integral calculus. E to the power c bracket t minus x come down dx dx e to the power c t minus x dx, where x will go 0 to t exactly the way it did with the 5. Okay, if someone calculated e to the power c t minus x dx integration, it will come as minus 1 by c e to the power c t minus x, now 0 to t. If someone places t there, it will become e to the power 0, that is 1. If someone places 0 there, then it will become e to the power c t. Outside minus is waiting, it will become 1 by c in bracket e to the power ct minus 1. This is what is published in every book. I have seen it. What is the banking solution? Now banking solution is yt equal to y0 e to the power ct plus s into 1 by c bracket e to the power ct come down minus 1. E to the power ct come down minus 1. Or in one go, yt equal to y0 e to the power ct plus s by c, and in bracket e to the power ct come down minus 1. This is what is published in any book. Personally, I am not satisfied with this. When time equal to 0, then yt equal to y0 e to the power ct 0, y0. That will go away as 0 because e to the power ct minus 1 will be 0. So when time equal to 0, the amount in the fixed deposit is y0, perfectly. When time is 1 year, then if it is 1 year, then yt equal to y1. At the end of 1 year, y equal to y0 e to the power c into 1. E to the power c. C is the annual interest rate, 5%, 10%. 5% means 0.05, 8% means 0.08, that is the C, plus S by C, and in bracket e to the power ct minus 1. If I place t as 1, then it will become e to the power c minus 1. It will not be e to the power, so it will become s into e to the power c minus 1 by c, which may not be equal to 1. So this is false. Whatever is written in a book, it does not look like exact solution. Okay, yt equal to y0 e to the power ct plus s by c in bracket e to the power ct come down minus 1. Okay, this does not look like exact solution. If I try to find the money in the account at the end of 1 year, then it will be y0 e to the power c. Y0 will get interest for 1 year. Y0 e to the power c. Okay, plus it should be s only because s was deposited at the end of 1 year. There should not be any interest. There should not be any interest on top of s. Okay, in that fashion, it should become a kind of s only, y0 e to the power c plus s at the end of 1 year. But what we are seeing here, y0 e to the power c plus s by c in bracket multiplied by in bracket e to the power c minus 1. E to the power c minus 1 by c should resolve into 1. If it is resolving into 1, then only we can say that it is the perfect solution. What do you mean? E to the power c should behave like 1 plus c. Then 1 plus c minus 1, c by c 1. So is it that e to the power c is equal to 1 plus c? Okay, that is a question mark. 1 plus c equal to e to the power c. Is it true? If I take logarithmic of both sides, then it will become log of 1 plus c equal to c. Is it both are true? Yes, this can be true only when c tends to 0. If c tends to 0, logarithmic of 1 plus c will become c only, and on that side is c. 1 plus c equal to e to the power c. This is the question. If that is true, then e to the power c minus 1 will become 1 plus c minus 1, c by c. Okay, then it will become 1. Then s into 1, s will remain. This is what we want. Y0 e to the power c plus s at the end of 1 year. Okay, now we try to prove e to the power c equal to 1 plus c. Is it really true? Take logarithmic on both sides. It will become c e to the power c logarithmic is c only. C equal to log of 1 plus c. Is it both same? Yeah. If say c tends to 0, Natural log of 1 plus c, where c tends to 0, is actually c1. Okay, but that is a criteria. So this is not a perfect solution the way it looks like. So what is perfect solution? Then we will go for successive approximation in integral calculus. This is what we have invented, and we will take that help now. That what, sir, what are you saying? Okay, to get the successive approximation, many times we have demonstrated it. Successive approximation works in a fashion that if you have a discrete addition means you have summation like e to the power c t minus 1, e to the power c t minus 2, e to the power c and in bracket t minus 3, like that. At the end you have e to the power c in bracket t minus t. Okay, if that is the case, there is a summation of t item and each item is different in that fashion. Then question is arising, divide it into t part and each part should be same. It is same only when e to the power c in bracket t minus x. Means you are sampling a function called e to the power c in bracket t minus x. Yeah. And we are sampling, this is typically like e to the power c t minus x. We are sampling at x equal to 1, x equal to 2, x equal to 3, like that. T times we are sampling. At the end we have e to the power c t minus t. Okay, then it is right, sigma summation x equal to 1 to t e to the power summation of, we'll write again, sigma means summation x equal to 1 to t small t function over x. If I add function over x t times, then I'll get what we want. What is fx? Fx is e to the power c in bracket t minus x. X will start from 1 and it will go up till t. Okay, that will be equal to, can we think, imagine another function called gx. This is fx, gx, for which underneath area is same as the addition of all the verticals. If I draw fx, then it is like this. And we have verticals at different x. If I add all the verticals, then I get the required result. Okay, can I have another function called gx, and for which if I calculate underneath area, that area should be equal to addition of all the verticals. What is area of gx? Gx dx from lower limit to higher limit equal to sigma x equal to 1 to 2 fx. Addition of all the vertical fx should be equal to limit gx dx. If I find a gx like that, then I can solve this problem very quickly. Understandable? Now let's consider that I have fx at any x. I have a height as fx. Makes sense? Now I have another gx at any x. I have a height as gx. What is next sampling? Next sampling will happen at x equal to x plus 1. Okay, if I take this sub area in gx, this sub area should be exactly same as the the height what we are thinking at x height of fx at x any x. So this is fx. This height should be exactly same as gx x to x plus 1. This sub area height should be exactly same as height of fx at x equal to same. What do you mean? How many how many verticals you have? I have t numbers of verticals. Then take a function gx and divide into t subsections. First subsection is from x equal to 1 to 2. Next is 2 to 3. Okay, second last is t minus 2 to t minus 1. And second last is t minus 1 to t, and last one is t to t plus 1. We have divided into t sub area, where if I talk about any point x, then at this point we have gx from x to x plus 1. This is the sub area. If I add all t sub area, it should be exactly same as adding all the vertical bar of fx. Understandable? Adding all the sub area of the gx with each vertical bar between each vertical bar, adding will be same as gx dx from lower limit to higher limit. Here its lower limit is 1, higher limit is t plus 1, not t, because tth section, first section is between 1 and 2 of x, 2 and 3 is the next section, tth section will be t to t plus 1. Okay, anyway, let's try to match any x section, any x point. If it is x, then fx should be equal to limit x to x plus 1 gx dx. If both are same, then we have to find gx in that manner. What is fx? E to the power t, sorry, e to the power c t minus x, e to the power c in bracket t minus x. This is fx. The vertical at x equal to x. What is gx? Between x and x plus 1, what is the area? Limit x to x plus 1 gx dx. I have to find gx anyway. Leave the limit fx equal to gx dx. Gx equal to dfx by dx. We'll start from here. What is fx? Fx is e to the power c t minus x. What is its differentiation? Minus 1 by c e to the power c in bracket t minus x. We'll consider this as gx and we will start it. Minus 1 by c e to the power c bracket t minus x dx from x to x plus 1. X to x plus 1. If I do integration, then it will come as minus 1 by c. They will cut each other. And it will come as finally e to the power c t minus x from x to x plus 1. If I take it, e to the power c t minus x will become t minus x minus 1 minus e to the power c t minus x as per it. Okay, I can take out e to the power c in bracket t minus x as a common item, and in bracket it will become e to the power minus c, e to the power c and bracket t minus x minus 1 will become e to the power minus c, e to the power minus c minus 1. So e to the power minus c minus 1 is extra now that I have to divide. So left side we have e to the power c t minus x, right side we have e to the power c t minus x into in bracket e to the power minus c minus 1, come down minus 1. Now we will divide by e to the power minus c, come down minus 1. Okay, we'll try again. Okay, gx is minus 1 by c into what into 1 by in bracket e to the power minus c, come down minus 1. Okay, and then e to the power c t minus x. We'll do the integration again. It will come as integration will come as hope. I'm sorry, I think we made a mistake. Gx was dfx by dx. Fx equal to gx dx. Dx was dfx by dx. Dx e to the power c t minus x differentiation is minus c e to the power c t minus x. So minus c I have to keep outside, not minus 1 by c. Anyway, now we will start gx as minus c divided by in bracket e to the power minus c, come down minus 1, then e to the power c t minus x. If I do integration, then 1 by minus c will come out. That will cut each other and c term will go away. 1 by e to the power minus c minus 1 e to the power c t minus x, that will be the integration. If I set x to x plus 1, then e to the power minus c minus 1 will come out, and then e to the power c t minus 1 remain. They will cut each other, and finally left and right side are exactly same. E to the power c t minus x, e to the power c t minus x. Once we have found gx, gx is minus c by in bracket e to the power minus c, come down minus 1, e to the power t, e to the power c t minus x. This is gx. Okay, to find the full summation, we will integrate from 1, x equal to 1 to t plus 1. X equal to 1 to t plus 1. We'll try now. E to the power c t minus x integration will be 1 by minus c. So c will go away. Now e to the power c t minus x is in bracket by e to the power minus c minus 1. Now we have to set limit 1 to t plus 1. If I set limit like that, e to the power c t t minus x. X is x is minus x is t plus 1. T minus t is 0. It will become minus 1. E to the power minus c. E to the power minus c. And now we will put the lower limit as 1. E to the power c in bracket t minus 1. Okay, then it will become e to the power c into e to the power minus c. And here we have e to the power minus c. Okay, e to the power minus c will come out rather. And inside it will become e to the 1 minus e to the power ct. I believe it is alright. It will become 1 minus e to the power ct. And outside came is e to the power minus c divided by e to the power minus c minus 1. Let's multiply numerator and denominator with e to the power c. Then top will become 1 and bottom will become 1 minus e to the power c. Okay, if I multiply again with minus 1, then it will become e to the power ct minus 1, e to the power ct come down minus 1 by e to the power c come down minus 1. This is the exact solution. Okay, so what is your y now? Y, the compound interest y. Here y is yt equal to yt equal to y0 into e to the power ct plus s into in bracket e to the power ct come down minus 1 full divided by e to the power c come down minus 1. Let's take t equal to 0. Then right side s multiplied by 0. There is no s value. It will become y0 e to the power 0 y0. When t equal to 1, y1 at the end of 1 year, what is the principal amount there? What is the money lying there? Then y0 e to the power ct, y0 e to the power c with t equal to 1 plus s e to the power ct, t is 1, e to the power c minus 1 by e to the power c minus 1. Cut, only s will remain. That is exactly perfect. At the end of 2 years, how much it will be? We'll try now. At the end of 2 years, y0 e to the power c into 2 valid plus s and e to the power c into 2 minus 1 by e to the power c minus 1. E to the power c, e to the power 2c will become e to the power c whole square minus 1. E to the power c minus 1 into e to the power c plus 1 divided by e to the power c minus 1 will go away and it will become s into e to the power c plus 1. S e to the power c plus s. Exactly. After 2 years, it will become y0 e to the power 2c plus s e to the power c plus s. First s will get interest for 1 year and last s will not get any interest. This is perfect. This is the exact solution that is not mentioned in the book. What is the exact solution is y0 e to the power ct plus s in bracket e to the power ct come down minus 1 whole by e to the power c come down minus 1. This is the exact solution. Now someone will try left side. We took right side. If this is if this is fx, if this is fx, x is going like this. If this height is fx, then at x equal to x, we have fx. If this is fx, then we are talking about gx. Gx at x equal to x is this. This should be same as what the sub area in gx. We took sub area in between x to x plus 1. I can take sub area between x to x minus 1. Then again it should work. Means I am trying to say fx equal to limit x minus 1 to x gx dx. Dx we started with minus c e to the power c t minus x. We proceed. Integration of minus c e to the power c t minus x is 1 by minus c. They will go away e to the power c t minus x. Limit is x minus 1 to x. If I put x first, then e to the power c t minus x minus e to the power c t minus and in bracket t minus 1, it will become e to the power c. So first will become e to the power c tx, e to the power c t minus x Next will become, next will become e to the power c in bracket t minus, and in bracket x minus 1, t minus x plus 1. Makes sense? It will become e to the power c t minus x. I can keep outside, and it will become 1 minus e to the power c. This is what we think so. 1 minus e to the power c. This is what is. Now 1 minus e to the power c is extra. I'll divide now. Now gx is minus c by 1 minus e to the power c. And then in integrate gx is minus c by e to the power c, come down minus 1 into e to the power c t minus x. If I do integration, 1 by minus c will come out and they will cut each other. E to the power c t minus x, x minus 1 to x, if I put e to the power c t minus x minus e to the power c t minus x into e to the power c. They will cut, and what remains is e to the power c t minus x. Exactly same. It fits in. We have found gx minus c by 1 minus e to the power c into e to the power c t minus x. This is gx. If this is gx, then what is the full computation? Full computation, the limit will go. If I start with the x equal to 1 and we have taken left side, then it will start from 0 and it will go to t. Means summation x equal to 1 to t fx e to the power c t minus x. That is a discrete summation equal to limit is 0 to t gx dx. What gx we have found? Gx is minus c by 1 minus e to the power c, e to the power c t minus x. Integration will be 1 by minus c. Minus c minus will go away, and it will become e to the power c t minus x by 1 minus e to the power c. Limit is 0 to t. Let's fill in. If I put t there, e to the power c t minus t 0, that will come as 1. 1 minus, if I place 0 out there, e to the power c t minus 0, e to the power ct. It will become 1 minus e to the power ct by 1 minus e to the power c. Okay, if I revert it, multiply both sides, numerator and denominator with minus 1, e to the power ct come down minus 1 by e to the power c come down minus 1. Exactly same what we got there. E to the power ct come down minus 1 by e to the power c come down minus 1. Actually, it came as 1 minus e to the power ct by 1 minus e to the power c. But we can multiply with minus 1. Amazing, mind blowing. Okay, someone would say, why you are messing up with this kind of thing? What are you doing? I'm doing e to the power c t minus x plus e to the power c t minus x, like that. What are you doing? E to the power c t minus 1 plus e to the power c t minus 2 up to e to the power c t minus t. Then you start with the, just invert it, then it will become 1 plus e to the power 1 means e to the power 0 plus e to the power 1 e to the power c e to the power 0, or e to the power c into 0 plus e to the power c plus e to the power c into 2 plus e to the power c t minus 1. This is what you are trying. Yeah, this is what we are trying. Simple. E to the power 0 plus e to the power c plus e to the power c t minus e to the power c into 2 plus e to the power c in bracket t minus 1. T terms you are adding. Okay, then take the fx equal to e to the power x. Why you are taking e to the power c and t minus x? Not required. You just invert it. And now it is e to the power x, where x starts from 0 and it goes till t minus 1. Now start again. Okay, fx equal to e to the power x, and limit x to x plus 1 gx dx with right hand side and left hand side minus, x minus 1 to x gx dx. Find gx in both. I'll try one. Fx equal to e to the power ex, dx equal to dfx by dx. I'm sorry, fx equal to e to the power cx, not x, e to the power cx, where x is going from 0 to t minus 1. e to the power cx equal to gx dx. Gx is differentiation of this, then it will become c e to the power x. Far easy now. We'll try with c e to the power cx. C e to the power cx dx. Then integration will become cc will go away, e to the power cx from x to x plus 1. X to x plus 1 will become e to the power x in bracket e to the power c minus 1. I'll take e to the power c minus 1 as denominator to nullify it. Then dx will become c by e to the power c minus 1 e to the power cx. It will be perfect. Now do the integration. Integration is from 0 to t. Then e to the power cx integration will be 1 by c. cc will go away. E to the power cx from 0 to t. E to the power ct minus 1. E to the power ct minus 1 by e to the power c minus 1. So straightforward. Or someone can try with t minus 1, x minus 1 to x, try to find out gx, and then let's set the limit. We tried with the x equal to 0 to t minus 1. It will go left side now, minus 1. We tried with the x equal to 0 to t minus 1. Okay, then at the end it will go 0 to t, 0 to t, 1 plus will go. If I take left side, then minus 1 to t minus 1. If I find gx in this manner, then limit will be minus 1 to t minus 1. It should come as, or we can try what is there anyway. Okay, so what gx, if we start with the, it is tempting now. Start with the c e to the power cx. Integration is 1 by c. c will go away, e to the power cx. Limit is x minus 1 to x, means e to the power cx minus e to the power c x minus 1. Okay, it will become e to the power cx in bracket 1 minus e to the power minus c. It will become e to the power minus c. We will divide it, and that is the gx. Gx is c by 1 minus e to the power minus c, e to the power cx. Now we will integrate and set the limit minus 1 to t minus 1. If that is the case, then e to the power cx integration e to the power cx by c. cc will go away. E to the power cx. Limit is minus 1 to t minus 1. If I put t minus 1, it is e to the power c t minus 1. It is power ct into e to the power minus c. Minus, if I keep minus 1, then e to the power minus c. Makes sense? E to the power minus c will come out. E to the power minus c will come out, and it will become e to the power ct minus 1. It will become e to the power minus c by 1 minus e to the power minus c in bracket e to the power ct minus 1. Now multiply top and bottom, numerator denominator with e to the power c. 1 by e to the power c minus 1. Numerator e to the power ct minus 1. Same. E to the power ct come down minus 1 by e to the power c come down minus 1. Same. Amazing, mind blowing. How nicely, how easily we computed the continuous compound interest fundamental so easily. Can someone try? If someone is depositing money in the account, not regular S money, first at end of 1 year he is depositing S1 amount. At the end of 2 years he is depositing S2 amount, that is different. At the end of 3 years he is depositing S3 amount. At the end of T year he is depositing ST amount. Then what will be the money at the end of T years? Can someone calculate it? Integration, your mind blowing, amazing. I mean, this is not available in any of the book. Anyone can try. They do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone.